Let's see if I can speedrun this GCSE Maths paper in under 30 minutes. This is done on the iPad, so apologies for any poor handwriting. Timer starting now. As you'll see throughout this whole paper, I did leave some working and wrote most of it down. However, as I was trying to do it as quickly as possible, there are some bits I just left and did in my head. Now sit back, relax, and see if you can answer them as quickly as I did. This can be 1 minus 0.2, which is 0.8, divided by 2, which is 0.4. Perfect. 12 cubes. This here be 0.4, 0.4. Okay. 12 cubes in the box, work out total 12 blue cubes. Let's read that carefully. So we're going to do 12 divided by 0.2, same as 12 times 5, which is 60. Alright, question 1 done. Excellent. Let's move on. It's 50 grams of sugar, 15 biscuits. It's going to make 6, so we're going to times that by 4. 3 times as much flour as sugar, so 150 grams of flour. Therefore, we're going to times that by 4 to get us 600. Okay, so we get 600 grams there. Buys all butter. She needs to make 60 packs. Okay, so how many packs of butter do you need? So 60 biscuits, that was 4 as well. 2 times as much butter, so that's 100 grams. Times by 4. Okay, so that's going to be 400 grams. They come in 250, so we're going to have 250 500, so we're going to need 2 because 500 grams fills all of that. Highest common factor of 72 and 90. So, well, I know it's going to be that, but let's write this out. 72, we can split up into 9 and 8. Okay, I'm not going to split that any further, but we know this can go into 2 and 4. Therefore, 90 as well can go into 9 and 10, which is 2 and 5. So as we can see, we've got 9, 2 in both of these. Everything else is different, so that's 9 times 2, which is 18. Right. In space below, draw a sketch of the solid shape below. Okay, let's think what we could do with this. Okay, so we've got a plan, that's the base, so we're going to have a cylinder in terms of dimensions. We're going to have a cylinder that's going up like that there. Okay, that'll be fine. Obviously with units, dimensions, let's think we're going to have radius here as 2 centimeters and the height here as we had 2, 4, 5 centimeters. Okay, that's all fine. Okay, question 5. Shape A can be transformed by B. Reflection and translation. Okay, so we want to consider this. Find the value of D and C. Okay, so our reflection in the x-axis means it's going to be mirrored up to here. So that's 1, 2, 3. So that's going to be 1, 2, 3. Okay, and then that shape is going to look like that there. Quite funkily. So we then go across go from this point 1, 2, 3, 4, 5, 6, and then down 1. So that's going to be 6 minus 1. Okay, except obviously we need to do this carefully and go the other way because A is being transformed, which goes down to here, helps if you read the question, and then that's going to be minus 6 minus 1 instead. Rubber. Minus 6 and minus 1. Perfect. Next one, question 6. Always check you're working. Goodness. 2 pens in each pack of black pens, 5 pens in green, and 6 in them. Okay, so number of packs sold. So we're trying to find number of green sold. Okay, so we can say in each of these we've got black, there's 2 in each pack, and then red there's 5, and green there are 6. Okay, and then we know the number of packs sold was 7, so we could say number of black pens, that's 14 sold. 3 times 5, that's 15 sold, and 4 times 6, that's 24. So this is number of pens. Okay, and then 212 were sold in total. So if we add these together, we've got 20, 30, 40, 48, 53. Okay, 53. 212 divided by 53 is 4. Okay, so the number of green pens sold. Green pens was this end one, times this by 4. 24 times 4, you can work that out, it's 96. Excellent. Okay, find the length AB. QR is 10 centimetres, the perimeter of that one is 26, so all of those 26, and the area of this one is 45. Okay, so if we know this is 10 QR, we know this is 4.5 if that's the area. Okay, and then BC, B to C, this one is the same as that one, P to Q, which is 4.5. So if we say those two are 4.5, that gives us 9. 26 minus 9 gives us a value of, so let me draw that, 17. And then what we can do is divide those two by 2, because there's 2 of those lengths. So we're going to say 17 divided by 2 is equal to 8.5 centimetres. Right, that's all good. Let's check number 8 then. So question 8, we've got work out the estimate for this. So in terms of estimate, I'll probably round this to 60 and 100 because those two values are going to go nicely, because this is the square root of 1600, okay, which is going to be about, what am I talking about, 40? What am I doing? That's adding. Let's try and do this properly as well. Okay, so we're going to times these together, okay, which is going to get us 6,000. Okay, the square root of 6,000, well, 64 goes into 8, so we're going to say this is, if that was 64, okay, let's actually change that to 64 then to round it, so this here would be about 80. Okay, that's good enough for me. It's an estimate. Okay, 2.3 to the 6 is that. Find the value of 0.23. Okay, so for this we're going to be moving that 1, 2, 3, 4, 5, 6 decimal places. So that's going to be 0.1, 2, 3, 4, 5, 6 decimal places. Yeah, okay, so we're going to have this here. 0.000148. Perfect. Yeah. And then 5 to minus 2, well, that's going to be 1 over 25. 5 squared is 25. Negative means we put it on the denominator. Okay, mixed fractions. So let's convert these quickly. 3 times 2 is 6, plus 1 is 7 over 2. 1 times 5 is 5, plus 3, 8 over 5. 7 eighths are 56 over 10. So we're going to say, as a mixed number, 5 and 6 tenths, which is the same as 5 and 2, sorry, 3, if I divide that by 2 fifths here, 5 and 3 fifths. Question 10 then. Graphs of equation of this and this have been drawn out. Use graph to estimate, find the solution. So solution where they cross at this point here, so let's say that's x 2.25 I think, and y minus 1.35 I think there. Okay, so it's just where they intersect. And question 11 then. Complete table to show information about the ages, median. Okay, it's going to take a minute or two. In order, they're already in order, that's good. So median is just going to be 59 I think, yeah, because we've got this one here, it's nicely laid out. Lower quartile, and we've got 23, add 1, 24, sixth value, we're going to say 2, 4, 6, both of them 53, that's fine, and then 1, 2, 3, 4, 5, 6 back is 66, so we're going to have that as our upper quartile. He says people in coach A are younger than people in coach B. Is he correct? Well, the least age is lower, the greatest age is lower, the upper quartile is lower, the median is lower, and the lower quartile is lower. So we could say yes, every single value is yes. Let's think about our reason. We'll say all values are lower right. Rich says people in coach A vary more. Okay. Do they vary? Let's double check. So varying, we're going to be looking at our interquartile range, or the lower and upper quartile. So this here, rubber. 2, 3. This here, or in terms of this here as well, we can look at the range probably as well. So the range here would be 38, whereas the range here is 43. So let's just check which one he said. A varies more than B. No, that's not true. So we could say no. You just want to make sure we have a decent statement. The range in B is more. It was more than it? Yeah, more than in A. Right. Going fast. So 3 spheres. Okay. I don't actually remember doing this question recently. So let's see what we can do. Volume of Q is 50 more than volume of P. So we can say P is like having a value of 1, Q is like having 1.5, and then R 50 more than this. So 1.5 times by 1.5, so 1.5 squared. Let's think. This is going to be okay. Find the volume of P as a fraction of this. So we're going to say 1 and 1.5 squared. So if we're doing 1.5 squared, we can say that's going to be 2.25. So we're going to have 1 over 2.25. That's going to be the same as 9 over 4. Yeah, so we're going to say it's 9 over 4. Okay, 9 over 4 to 1, or 2.25 to 1. Okay, so that's 9 over 4 P of fraction of P, so other way around. Okay, because we're doing it of P here. So that's going to be 4 over 9, because it's going to be of this one, 1 over this. Okay, so it should actually be this way around here. Excellent. Given that n is an integer, prove that this can never be of. So with proofs like this, you want to consider n squared minus n can be factorised as n minus 1, and then here we can say either n or n minus 1 is even, as they're consecutive numbers. Consecutive, therefore an even times an odd equals an even number. So it's never odd. Never odd. Perfect. Okay, we'll find the exact value of these. So tan 30 and sine 60. So hopefully you can remember, if you've got a right angle triangle like this, where we've got 30 here, this is 1 over 2, because sine 30 is a half. That's the best one to remember. And then you can work out the rest of this. So this is 2, we're going to have 2 squared minus 1, which is 4 minus 1 square rooted from Pythagoras' theorem. This is root 3. So tan 30 is opposite over hypotenuse, 1 over root 3. Sine 60, if we do it the other way around, that's the 60. We can say opposite over hypotenuse, which is, adjacent over, sine opposite, there we go. So we could say sine 30 equals root 3 over 2. So if we're trying to calculate these, we're going to say this here is these two times together, which is 1 and just a half there, because the root 3's cancel each other out. So for this, work out the total volume of this here. Let's have a look at this shape. Cone, hemisphere, okay. Volume of the shape is k, where k is an integer. Okay, so we need this as an exact value. So let's do the cone. So we've got a third pi r squared h, which is a third times pi times 3 squared, because the radius is 3, and then times my height, which is 10. Okay, so this gives us a value of a third times 3, that cancels one out, so it's going to be 3 times 10, 30 pi. Okay, and then the sphere, we've got a hemisphere, but we've got the sphere here. How are we doing for time? We're at 14 minutes. Okay, question 15, not bad. Question minute. and then we're going to say volume of sphere 4/3 pi r cubed, and then we're going to have to divide this by 2. So we're going to say this is 4/3 times pi times 3 cubed, all divided by 2, so we don't forget. Okay, so this here, the 3 and the 3 are going to cancel here and here, so we're going to have that's 3 squared. 4 times 3 squared, 4 times 9, 36, divided by 2, we'll do that straight away for time. That gives us 18 pi, so we've got 30 pi plus 18 pi, which gives us just a value of 48 pi. So, okay, in this question it's 48. Right, 16. Okay, we've got padlock, number of locks. 3-digit number is this. Work out possible number that can have for this lock. It can only be 1 to 5 here, not 1 to 10. So we're going to say this is 5 to the power of 3, because there's 5 of them. Three different combinations. Each can have 1 to 5, which should be 125. My cube numbers. How many possibilities? 3-digit numbers have 3 different digits. Well, let's think. How many possible 3-digit numbers have 3 different digits? Okay, so this can be a probability. So the first one could have 5 different possibilities. Then if we've used that number, we can only have 4 after that, and then 3 because the other 2 numbers have been used. So this here would be 1260. There we go. Or 20 times 3. Okay, so we've got ratios, so we're going to say this here, x squared goes to 3x plus 5, which is the same as 1 to 2. So we could write this as a fraction. Okay, we could say x squared over 3x plus 5 equals 1 over 2. Okay, multiply both sides, so we get 2x squared equals 3x plus 5, and then move it all onto one side. 2x squared minus 3x minus 5 equals 0. So from this, we then want to think about our quadratic formula. Does it factorise? Let's have a look. 2, 1, 5. Yeah, I think we possibly factorise this 2x. X, one's going to be negative. If we say negative 5, no, that's not going to work. Plus 1 minus 5, that gives us minus 5x plus 2x. Yeah, this works. Okay, so for this we could say we end up with the value of x equals negative 1 is one of the solutions. 2x minus 5 is 1 equals 0. 2x equals 5. So x equals 5 over 2 as another solution. So we've got minus 1, and so that's 2.5 as a number there. Okay, can't be 0. Yeah, that's all fine, I think. Okay, question 18. Right, okay, so we want to split the root 12 by saying this is root 4 times root 3. Okay, so we end up with root 3 plus 2 lots of root 3. Ooh, tidy that up a bit. Okay, which would then give us just a value of 3 lots of root 3. Okay, and then let's have a look at question part B here. Okay, so if we're doing this to the power of 7, it's like saying that's 3 cubed. 3 cubed is 3 cubed, 3 squared, cubed, half that. Let's think about this for a second. So yeah, 3 cubed, we can just take out the fact that we've got 3 cubed. So this is 1 over root 3 to the 7, and then this is the same as 1 root 3 all to the 6 root 3. Okay, so this here is the same as 1 over 27 root 3. In terms of this, we're going to rationalise probably because we've got root b on the top. So if we multiply both numerator and denominator by root 3, we can say that's root 3 over 27 times 3. So that's going to be root 3 over 81, I think. Root 3 over 81. Obviously, in more time, we can check through these a bit better. X squared minus 6x plus 1. Complete the square of all values of x. Find the value of a and the value of b. Well, straight away we can see a is 3, and then 3 squared. So if we actually complete the square, we'd say x minus 3 squared minus 9 plus 1. This here is going to go to minus 8. Okay, so b, go to the rubber, would be 8 here. Now, hence write down the coordinates of the turning point. So you need to set that equal to 0. So x is going to equal 3. And then this here, whatever's left, is your y coordinate. So this here is our minus 8. Okay, so this is your x, this is your y. Okay, goodness, inverse proportion. So h is inversely proportional to p. Okay, and p is directly proportional to root t. Okay, so if we were going to write this in terms of this, we could say h is directly proportional to 1 over root t. Okay, so given that h is 10 and t is 144, when p is 6, find out h in terms of this. Okay, so we obviously need constants here, so we're going to say h is k over p, and p equals, we'll do a different variable, we'll do c root t, just to show a different constant, and then we're going to say, for the first part, because we've got h and p, so we're going to say 10 is equal to k over, this was 6, I think, p was 6, yep, so k is 60, okay, and then p here, p was 6, 6 equals c lots of root 144, so 6 is equal to c times 12, so divide that across, c is a half. Okay, so what we're then going to say with this is, put that all into the equation, find a formula for h in terms of t. So we've got this equation here, h is equal to, and then we need to consider our 60 and our half. So we're going to say, we had that, let's do a completely different variable, let's just say it's a at the moment, over root t, and then we need to combine these together. So we've got 60 divided by a half, which is 120, which is going to be our a. 60 divided by a half, a is 120. So we'll end up with h is equal to 120 over root t. I think for this one, that's good. And then let's look at the function one, 21. Okay, so we've got inverse functions. So if we say f(x) equals 3x minus 1, so we can rearrange this. We say this is y plus 1 equals 3x, x equals y plus 1 over 3. So this is going to be x plus 1 all over 3. We just replace x and y at the end there. Show that f(g) of x is equal to 2g f of x. Okay, so if we start off with f(g) of x, we can say that this is 3x squared plus 4 minus 1. Okay, so that's going to be 6. We're going to have 3x squared plus 12 minus 1, 3x squared plus 11. Okay, then let's see what we can say with this other one. If that equals this to g f of x, so put them in the other way round. So we say this is 3x minus 1 all squared plus 4. Okay, so that is still technically equal to this. We just need to put that into this. So we say this is 9x squared minus the 6x plus 1 plus 4. Okay, 9x squared minus 6x plus 5. So if these two are equal, let's move it all onto one side. 0 equals 6x squared minus 6x, and then that's going to be 5 minus 11. That's going to be minus 6. This doesn't look right. What have we done here? 2, don't we? That's why. Times this by 2. Okay, so let's just rewrite those terms. We've got 18 minus 3 is 15, yep, and then 2 times 6 gives us minus 12. X, 2 times 5 is 10, and then that's plus 10 minus 11. That should just be minus 1. Was that what it was? Yeah, all equals 0. Perfect. And that's now shown. Do it carefully. Remember the 2. Right, question 22 then. Let's have a look at this one. Red counts in a bag. Probability to pick a green one. Okay. Probability of a green counter is this. Counter is put back in the bag. 2 more red counters and 3 more green counters. Okay. Okay, so first thing we want to start off with this one is basically try and find some sort of relationship between R and G. Counter thing, probability is green, so we can say G's probability initially is 3/7. 2 more red and green counter is then 6/13. Okay, so for this we're going to be thinking about okay, so it's going to have to be a multiple of 7. 1, 2, 3, 4, 5 more. Okay, so we've got 5 more counters being added. So multiples of 7, we've got 7, 14, 21. Add 5 to that, we could then get multiple of 13 would be 26. Okay, my gut instinct is maybe 26 counters at this point. Let's see if that works. How can we then put that together? So we could say initially number of green over the total, green plus red, is equal to 3/7. And then let's try and create a new equation for this. We could say greens we add 3 to, and then in total green plus red we add 3 green and 2 red, and this all then will equal our value of 6/13. Okay, so this is G plus 3 over G plus R plus 5 equals 6/13. Okay, oh, that's the last question. So what we're then going to do with this, we could try and think, what else could we do? Let's try to get rid of a variable here. We'll multiply things across. So if we put 1 in terms of the other, R would equal 4/7 at the start. That's also something. If we take R out, okay, let's think. So if we rearrange this, if there's 3, we could say a fraction of G over R. There's 3 greens for every 4 reds, so we could say this is 3/4. So we could put all of this in terms of one another, so we could say 4G equals 3R by rearranging that equation. Now pick your choice. We say that's equal to that. Let's try it in this other equation at the bottom. 4, so we could say that's 5G. No, what am I talking about? We could say this is G plus 3 over G plus, if we divide this by 3, it's going to be 4/3. G plus 5. Okay, equals 6/13. Move that across, so we've got 6 times that. Surely there's an easier way than this. Let's think. Can we create a simultaneous equation here? 7G, 3g plus 3r, that might work. Okay, let's just continue with this then. We'll say 13g plus 39 equals 6g. I'm going to need some more space here, but a 6g plus 4 times 3, that's going to be 4 times 2, 8g plus 30. Okay, let's rearrange that. So that's 13g plus 39 equals 14g plus 30. Okay, so I can see that as 9 equals g. Okay, so I think we're going to have 9 green counters, and then 4, divide that by 3 times by 4, we get 12, and that gave us 21 counters at the start, and then 26. Yeah, I think that's all good. Right, let's see what we did it in 30 minutes just. Not too bad. Right, let's double check we didn't miss a question, but yeah, other than that, I think that's all good. As you can see from this paper, we got 79 out of 80, made one mistake, well, it happens, mixed up an A and a B, but yeah, pretty good for a speed run. Thank you very much for watching, I hope you enjoyed it, and see you in the next one.